I am Blaine Carter, Oracle's developer advocate for open source. There's my contact information if you need to get a hold of me for any questions, comments, or suggestions. In this series, we're going to take a look at using the CX Oracle open source Python utility to perform some basic cruD operations against an Oracle database. cruD, of course, being create, read, update, and delete. For those who prefer a written tutorial, this series and all of the examples can be found on my blog at learncodeshare.net. Before you get going, there are some prerequisite steps that can be found in the introduction and setup video. In this section, we'll go over deleting data from the database. We'll delete single and multiple records, talk about how foreign key dependencies affect the deletion, and look at a couple ways to use those foreign keys to simplify the process. I'll be using a helper function called getAllRows. Basically, it's just a simple select statement that we'll use to verify that the data changes worked. The select functionality is covered in the read section of this series, so we won't go into the details here. To keep the examples clean, I will reset the data from time to time. I'm going to use a file called resetdata.py. This file won't be covered in the tutorial, but you can find it on my blog. Let's delete some records. First, we get a cursor from our connection. Then we prepare the delete SQL statement using positional bind variables. Then we'll execute the prepared statement using the ID value of 1. And finally, we'll commit. When we run the code, we can see the original data from before the change, followed by the remaining records after the delete. Let's remove all of the birds from our data. We simply change our where clause to type equals bird. And you can see in the results that both of the birds, dragon and red, have been removed. We're going to reset the data and change the boilerplate so that we can display both the people and the pet data. If you're using integrity constraints in your database, and of course you are because then you let the database do some of the heavy lifting for you, you'll sometimes need to change the way you process your changes. In our database design, we have a foreign key constraint on CX pets, which ensures that if a pet has an owner, that owner actually exists. If we attempt to delete a person who has one or more pets, we get an error telling us that we have violated an integrity constraint. This is our foreign key in action. With this foreign key in place, we must deal with the pets before we remove the person. Depending on our database design, we have a couple options. If pets are not required to have an owner and you only want to delete the person, not the pets, then you can update the pets and set their owner to null. If pets are required to have an owner, then you can update the pets to have a new owner or delete the pets before the owner. Let's say Bob is moving out of our area and his new apartment doesn't allow pets. Now, we don't want any abandoned pets, so we'll use the second option and move them to Kim. In the code, we get a cursor object from our connection, prepare a SQL update statement, changing the owner to 2, which is Kim, for all the pet records with an owner of 1, which is Bob. Updating is covered in the U part of this series, so we won't go into that now. We execute the statement using bind variables. Then we prepare a SQL delete statement, deleting people with an ID of 1, which is Bob. We execute the statement using bind variables. And finally, we commit the transaction. In the results, we can see that Bob has been removed and all of his pets have been moved to Kim. For an alternate solution, we can leverage the power of foreign keys. When you set up your foreign key constraint, you can tell it how to handle the previous situations. Now, by default, the database will simply throw the error that we saw before, but we do have a couple other options. For example, you could use a cascade delete. This way, when you delete a parent record, the database will automatically delete all of its children. Another option is, if your database design does not require that every pet has an owner, you could use onDeleteSetNull. This will just set the foreign key column to null in the child record if the parent is removed, but the child record will not be deleted. In either case, be aware that the action will just be performed and it will not have an "Are you sure?" check first. You can find some more information on foreign keys here. That's a quick overview on using Python and CX Oracle to delete data from the database. All of the example code can be found on my blog at learncodeshare.net. If you find this useful, please like the video and subscribe to my channel. Thank you.